In this video, we're going to go ahead and get some BGP peerings set up so that we can actually get into the configuration part, which is what I know all of you are really wanting to see and for us to get going with. For us to basically understand how BGP works from the fundamentals to the practicality, there's two different fundamentals you have to understand. That there's two different neighbor types. You have an external BGP, which is neighbors outside of your autonomous system, and you have internal BGP, which is going to be neighbors inside your autonomous system. So, depending on how you're peered, will determine how you choose your paths and how you route to the next hop. When it comes to iBGP versus eBGP, when it's iBGP transport establishment, the packets are defaulted to a TTL 255, which means that neighbors do not have to be directly connected to you. And typically, you're going to peer via the loopback, and you would use the update source command to accomplish that. This allows you to have dual connections to all of your routers, so that if a link goes down from between two routers, you can reconverge around and to the other side. But because of the fact that BGP is a TCP application, there really is no such thing as reconvergence in the iBGP, because as long as the IGP has a route to the loopback, then and typically speaking there's going to be a dual path to get there, then you won't have to worry about having to reconverge, because that's where traffic is going to be coming from anyway. So if the routes are already in the routing table and a link goes down, that just removes that route from the routing table. Whether it's eIGRP, BGP, or eIGRP, RIP, or OSPF, doesn't really make much of a difference. As long as IGP has a backup route that is, or if both routes are in the routing table and one happens to go down, it's just removed from the routing table and the other one's still there. So there is no reconversion, so to speak. So from a peering configuration, you are going to use the same syntax for both eBGP and iBGP. The only difference between the two is with eBGP, your autonomous system number will be different than theirs. So if you type in router BGP1 and you peer with router BGP2, and the remote AS is 2, that's going to be somebody outside your autonomous system, which means that's going to be an eBGP peering. So the basic breakdown to it is relatively straightforward and simple. It's understanding the details to it that are sometimes a little hard to grasp. So what I'm going to do before we get any farther is I'm going to go ahead and I'm going to show you how to peer an iBGP peering and then an eBGP peering, just to show you what it looks like. And then we'll get into some of the more advanced parts as we go along. I think that will reinforce what you guys have learned so far. So what we're going to do is I'm going to pull up Paint, and what we're going to do is we're going to peer between router 3 and router 6, but we're going to peer off of the directly connected interface. Now you can peer via eBGP, and it can be more than one hop away. But actually, let me cover that real quick because I haven't gotten to that part yet. Because eBGP, you need to have your peers on a directly connected subnet. But what if you don't? Well, if you don't, then you need to add in a couple lines of syntax to let the router know where he should be learning it from. So you could use, if you're going to use the neighbor, the IP address of the remote neighbor's IP address, and the remote AS or whatever that autonomous system's number is, that's not yours, then you would form a peering. But what happens if you're peering off loopbacks like you would be with iBGP? Or the guy you're peering with is, 700 routers away. Well, it wouldn't actually be 700 because that would be way outside the TTL value. But let's say it's 70 routers away. Let's say it's too far away for it's not directly connected. Let's say that much. Let's actually take that back. It's not directly connected to you. So you have to use the term eBGP multi-hop. And then from there, you'd have to have a route to that particular neighbor. So we'll take a look at that as we go along too. So I think that would help out. As long as you have a route to it, whether it's you're receiving it somehow and you want to form a peering with it, or you have to configure a static route to point to the next hop to say, okay, and if you want to get to there, you need to go to here to get there. So first thing we're going to do is we're going to do our eBGP peering here, directly connected. I'm going to do an iBGP peering here. So we have our BGP here is 1, 2, 3, 4, 5, and our we have 1, 2, 3, 4, 5, and 6. So I'm going to pull up our configuration. I'm going to go to router 3, and you can disregard the OSPF stuff. I don't know why that's acting up on me. I'm going to go to global config. I'm going to type in router BGP 1, 2, 3, 4, 5. I'm going to type in neighbor of 36.0.0.1, remote AS of 6. Okay. I'm also going to type in neighbor of 10.255.5.5, remote AS of 1, 2, 3, 4, 5. And on this one, I had to type in the update source. This would be my loopback 0. And that's all I'm going to do. Now I'm going to go to 5. And from here, I'm going to type in router BGP 1, 2, 3, 4, 5. Type in neighbor of 10.255.3.3. Remote AS of 1, 2, 3, 4, 5. Now, one thing I'm not going to do is I'm not going to use the update source. The only reason I'm not going to do the update source is because of the fact that this guy, router 3, was trying to send the packet to router 5, sourcing it off of his loopback, and because we're trying to send it we're sourcing it off this address, because router 5 knows how to get to this address, I don't have to specify where it's coming from because it matches where the traffic is coming from. Now, if I was sourcing out the fast 1/0, which is 172.16.35.3, if I was coming off that address, that's going to be different than this guy. It wouldn't match and the peering wouldn't come up because he's receiving a TCP update or a TCP open message from the wrong address. Now let's go over to 6. I'm going to type in router BGP 6. Type in neighbor of 36.0.0.2, remote AS of 1, 2, 3, 4, 5. And now we should form a BGP peering over there. It might take a moment for it to actually kick in, but we will eventually get it. And we type in do show IP interface brief. I'm a little impatient sometimes. Oh, that's why. I'm 36003, and this guy is do show IP interface, or I'm sorry, 6. Do show IP interface brief. This guy is 1. So on 6, I have to do the no and hit the up arrow. Put .3 in here. Pull the no out, and then that should fix that. There it goes. Yeah, there's a comment, a ping. The reason why you would ping is that would verify you have at least layer 3 reachability to the next hop. So if you can't ping, you won't be able to form a BGP peering. And if you can't ping, that could mean just a couple things. Either the network or the interface is shut down, it's on the wrong layer 2 subnet, it's got the wrong layer 3 address configured to it. There could be just a handful of things that could be the problem, but those are things that's layer 1, layer 2, layer 3. And as long as you can ping it, that means that everything else up to that point is working. Now, as you can see, if we go back to router 3, I type, click on router 3, and we type in show IP BGP summary. I have 2 peerings. Now, if I was to go to global config and type in router BGP 1, 2, 3, 4, 5, and type in neighbor of 10.255.2.2 remote AS of 1, 2, 3, 4, 5, and do the same thing, do show IP BGP summary. Notice how I have 0 and 0 here for these 2 connections, but I have an idle sitting here. Notice where they're sitting too. The state is idle, the prefix is received is 0. What the prefix is received 0 means is that I have formed an adjacency with them, but I haven't advertised any routes. That's why I was mentioning earlier that BGP and the control plane and the data plane are completely separated. Now, unlike iGP, where once you form an adjacency, you start advertising routes. As soon as you're going from one interface to another, and you're using the routing protocol to advertise those routes. So the general idea is this: if you form an OSPF peering between router 3 and router 5 on this link right here, what's going to end up happening is if there's no other adjacency, you won't actually see the O routes show up because of the fact that they're directly connected to each other. It's when you would have a route from 2 to 3, this link in here being advertised in OSPF, 3 advertising it to 5, then it would show up as an O route for the 172.16.23 network. So router 5 would know to go to router 3 to get to the destination. Now, when you do that, you're automatically advertising routes. Now, advertisement and getting the OSPF process to be enabled on an interface that matches the network statement, or actually I should say, turning the OSPF process on an interface that matches the network statement. I know I just repeated myself, but if the network statement doesn't match an interface's IP address, then the OSPF process won't be enabled on that interface. Now, because of the fact that OSPF and eIGRP automatically form automatic neighbor relationships as long as the network commands are correct or the neighbor statements are correct, then what ends up happening at that point is you have that dynamic capability built into it. BGP is still technically a dynamic routing protocol. However, you don't form neighbor relationships by default unless you enable it. And you would use that by the listen command. The listen command allows you to say, okay, I want to learn routes dynamically through BGP, and you have to specify where traffic will be coming from. So, for instance, if you have a large-scale DMVPN deployment, and you want to listen for iBGP neighbor relationships coming in, so you want to run iBGP as your DMVPN overlay protocol, you can do that. So what you would do is with the listen command is you would have to go out and you'd have to learn, have to know all of the remote site or the remote spoke public IP address ranges, and you'd have to make sure that the listen command has a that particular route or that particular subnet is inside of the peer group that you would apply to the listen command. Now you're probably like, what? We'll talk about this more in detail, but the general idea with the listen command is you have to tell it what it's to listen for, and if you don't tell it what to listen for, it won't form an adjacency. It'll be like, well, I'm receiving traffic in, but it doesn't match anything that I have set up to configure with, so I'm going to drop the traffic. So it's like its own built-in control plane protection, if you will. Control plane protection is going to be how the routers talk to each other via the routing protocols. And then management plane would be your SSH and Telnet and SNMP. Your data plane would be your traffic that's going to be in the data plane, like your voice and your video and things like that. And access lists are going to be how you would manipulate that. Prefix lists are going to filter on prefix length, things like that. So it's important to know the differences between them. And there's a question: what is the backplane? The backplane is going to be the plane. I'm quoting this. The backplane is going to be the capability of how fast and how accurately you can route traffic from interface to interface. So just to break this down so you understand where I'm coming from. When you are dealing with BGP and you're forming just neighbor relationships and you're not advertising any routes, you're dealing with the control plane. You're determining how you're going to scale your BGP environment. So when you have it set up, you're going to be using the control plane to form adjacencies. When you want to, you're going to be using control plane protocols like OSPF, eIGRP, BGP, anything that when the router is talking from router to router, that's control plane to control plane. And the routers will, I don't know if you know this or not, the routers will automatically add a quality of service marking to make sure that the control plane traffic has more priority over just any other type of traffic, whether that's management traffic or data plane traffic or whatever the case might be. The control plane, and the reason for this is the control plane is also the hello protocol. So when you're sending hellos back and forth, you want to make sure that the router, your neighbor, gets it. Now, management plane is when you want to SSH or Telnet. I'm consoled into the boxes, so I don't have to worry about management, but the console still technically is management. But it's management that is not coming through the TCP/IP stack. I am coming in through a console section, and there's a question: how do you know what port to connect to? Well, if you were to be in GNS3 and to hover over a router, if you were to look at the console port, typically they start off at 2101 and they move up. Router 1 is 2101 and they move up numerically. So if you were to type in the IP address of your computer running GNS3, and then in the port number where it would be telnet, so you would say you would telnet to it, you would telnet to the console port. And because GNS3 is emulating all that, it would be like I'm consoled into the box. So if I was to go on here, and then if I was to jump out of here and do a show users, I'm consoled in. So that's how you would look at that. Now if I was to do show line, I have all these lines. Now here I am, and the reason I know that I'm consoled in is because I have a star next to it. And now you can see that I don't have anything else going on. If I was telnetted in, I'd be on one of the VTY lines, 2, 3, 4, 5, or 6. So that's how I know where I'm at. So that's the general idea of how you would look at that. So that's how I know how I'm connected to the box, and if anybody else is connected to the box, I can take a look at that. Because I could be looking at it and all of a sudden things start going a little slower. Because if I was to do a show processes CPU sorted, you would see that the highest utilization is going to be the ones that are going to be doing the most amount of work, which right now PPP is, because I'm running PPP on these routers. And I'm not doing anything like I was in the previous videos. If you watch the first bunch of videos that I did, those videos were are done, so we're good to go. But the problem that I ran into is the box, or the Windows box that I was using to handle all that got corrupted, and so I had to rebuild it. And so I just rebuilt GNS3. So just give you guys an idea how to break this down. This is PPP. Then we have IPAM, which is IP Address Manager. And then we have PPP Events. Then we have the BGP router. And the reason this is popping up is because of the fact that we're running BGP. Then we have IP input. This guy right here, IP input, is going to be how your router is forwarding traffic, and IP input means it's process switching. So because this is a software router, I don't really have much of a choice on that. So we have that set up as well. So these gives you an idea, and you'll learn what the different processes are after time. I mean, if you understand how to look at different different outputs and know how to interpret them, I mean, this is, I wouldn't expect you to know this stuff, or you know, but in case you do need to want, in case you want to know it, it's good to know it. And you can go into I believe it's iOS fundamentals, and it goes into that. I believe there's a full PDF on that. But so that's basically how that would work. Now, I formed a peering. Let me hit the up arrow a couple times. Okay, so I formed a peering to 2. Okay, now 2 is receiving this traffic inbound. If I was to go to 2, and if I was to go in here, and unfortunately I don't know if there's a way I can debug. I think there is. I'd have to do like a debug IP packet and just do BGP. But right now, if I did a if I go to global config and I turn BGP on, so I type in router BGP 12345, I type in neighbor of 10.255.3.3, remote AS of 12345, we shouldn't get it to come up. And the reason for that is because of the fact that on router 3, when I did my config, so show run pipe section BGP, I didn't tell it what the update source is going to be. So I never gave it an update source. I gave 5 an update source, but I never gave router 2 an update source. So what's actually happening is if we were to do a debug IP packet, you would see the traffic is being sourced out the fast1/1 interface, which is coming from the 172.16.23 network. Now I'm trying to source out the loopback. Now if I were to go to router 2 and do a do show IP route, I know how to get to 3. Because in fact I have a route to it. So that's not the problem. So do ping 10.255.3.3. I can ping it. That means I have reachability to it. Now if I went to 5, or if I went to here, I just type in, hit the up arrow, and bring this back and type in update source is loopback 0. That should fix that. Because now I'm sourcing it out the right network, and the adjacency comes up. Because all I have to do is tell it the right update information, and it should come right across. That's the point that you want to make sure you understand. So I formed a couple of iBGP peerings, and we're good to go with that. Now, one of the things that I'm gonna stop this video because I don't want to get these. I don't want them to become too lengthy. What we're gonna take a look at in the next video is some of the more advanced concepts to get you guys get your what's your whistle. Now, there's a question when it comes to advertising routes. How would you do that? Well, you do it similarly to the way you would do it with iGP. You would advertise the route, whether it's depending on how you want to advertise it and what path selection needs you might need to provide capabilities for. So we'll take a look at how that would be done. I don't want to give it away right at the moment. I'll show you guys how to do that coming up. But I want to step this in because unlike iGP, like OSPF and eIGRP, you guys have seen that. Now I'm assuming you're coming from a CCNA level and you've never touched BGP. So if you've never touched BGP, this can be a problem. So as we're going through here, you'll see that I don't go as slow in iGP as I do with BGP because I'm assuming you've never touched BGP before. So what we're going to do is router 3 and 5 on our side is going to be they're both going to be route reflectors, and I'm going to have 1, 2, and 4 as route reflector clients. And what I'm going to do is when router 3 and 5 receive an update from router 6 or 13 or from 15, what's going to end up happening is those routes that are going to be eBGP will be received in on the edge, so 3 and 5, and will be replicated down to 1, 2, and 4. Now by default, iBGP does not do that. And I'll show you what I mean. And I'll use a route reflector to fix that. Now the general idea is you have to understand the next hop processing and stuff like that, which we're going to be getting into in the next videos, and how you would get route reflectors to work. And there's a question: am I going to cover confederations? No, I am not. I will give you I'll break down what a confederation will do, but I won't go into the configuration because it's way outside the scope of route switch. That's more of a service provider technique. So that's where that sits. So that's it for this video. I hope this has been informative for you, and I'd like to thank you for viewing.